Okay, so also from my side, welcome to the annual member meeting of IOLINK. Today I'm going to tell you something about how we integrated IOLINK in our product and just to show you what are the benefits of an IOLINK product compared to other products. First to my person, my name is Philipp Zuber. I'm coming from the company Schunk. And I'm working there at the product marketing department. So we are responsible for the market launch of new products. And yeah, I'm going to start to introduce the company. So for those of you who do not know the company Schunk, we are a family-owned company, German company. We have about 3,000 employees all over the world. And we have also more than 30 subsidiaries all over the world, so our products are sold worldwide. We have two business units. On the one hand, we make products for clamping tools and workpieces. So, for example, we produce tool holders, but also lathe chucks, stationary work holding. And all stuff for clamping workpieces or tools. The second business unit is gripping systems. There we manufacture products for industrial automation. So the most famous product is the gripper itself, but we also have components for other kind of automation, for example, linear axis or robot accessories, or different other stuff. So when you look at the robot, we can offer the complete tools for the end-of-arm handling. Like you see on the top, rotary feed-through, so for feeding through signals, electrical signals, but also pneumatic air. We have monitoring devices, collision sensors, for example. We also have changing modules, tool changers to have different kind of grippers, but also to have other tools for operating at the robot. And as I already mentioned, the most famous part is the gripper itself. And this is also the most important tool in an end-of-arm handling, because it's directly at the workpiece. So all the information and all the stuff which is generated directly at the workpiece are analyzed by the gripper, and so the gripper also has to be flexible and has to grab all the information directly from the workpiece. So we decided also to make our gripper a little bit more intelligent, and this is why we integrated the IOLINK communication in the gripper. But at first I want to give you an overview of what is our portfolio. So we have pneumatic gripper on the one hand, small parts, universal long stroke grippers, and we also have electrical gripper on the other hand. Electrical grippers are a little bit more flexible because in general it is possible to adjust the force, to adjust the stroke, to grip different workpieces, compared to a pneumatic gripper, which can only do two positions, open and close, and is always gripping with the same gripping force. In the last years, the mechatronic grippers, they were increasing more and more because production flexibility is required more and more. And so we also tried to set up a strategy for our portfolio to make it more understandable for our customers. And this is why we invented a mechatronic strategy. But I will come to that later. At first, I want to show you the pneumatic grippers. So at a pneumatic gripper, it's very simple. So the movement is only open and close. It is not possible to position the jaws or something like that because air is either inside or outside. But the benefit of a pneumatic gripper is that we have very high forces at a very small size. So it's very effective regarding the force, but it's not flexible. So we do not get any data or feedback or information from the gripper. It's only possible to mount external sensor system to the gripper to monitor the position of the jaws and so to detect the workpieces. So this is either possible with magnetic sensors, with inductive sensors, and we also have sensoring with an analog system to detect different positions over the stroke. But with the analog signal, it's always a problem with interferences because the signal is very sensible. And so we had sometimes problems with that. So the first step was to implement an IO-Link sensor for the monitoring of the jaws of the gripper. This is a CNUT sensor which can be put into the CNUT of the gripper. And with this IO-Link sensor, it is possible to detect different positions along the stroke. We also get, because of this detection, we can identify different kind of workpieces. So if the gripper grips different diameters, then it is possible to analyze what workpiece is gripped at the moment. And we are also getting more information out of the sensor, out of the gripper. We get information about the temperature, the quality, and the sensor ID. So not only the workpiece itself or the position of the jaws, but also more information. And one more benefit for the IO-Link sensor is that we have no problem with interferences regarding the signal. So it is possible to transfer the signal very easy and without any interferences. And this is in industrial applications often also a main benefit. So now I'll come to the electric grippers. As I already explained, we have a strategy for our products. So on the left side, you see alternative products. In the past, most of the customers were using pneumatic grippers, and then they started to change. But for many customers, it was a little bit difficult because an electric gripper is very, or it's more effort to program, to get it commissioned or to get it started up. And so many customers are a little bit, they have fear to change to electrical systems. And this is why we developed alternative products which are as easy as pneumatic products and have the same function and the same performance as pneumatic products. And these alternative products are also controlled via digital IOs, but this means that the gripper can only do open and close, like same as a pneumatic gripper. It's only electrically driven. The second pillar is called adaptable. These are components where it is possible to mount an electrical servo motor on the product. So the customer can control the component directly with a servo motor within his controlling or within his controller where he is used to, so where he knows everything about it. And the third pillar is intelligent. So intelligent means that with the gripper it's possible to do mostly everything, to adjust the fingers, to do different kind of accelerations, to do different kind of gripping forces. So be very flexible and to adjust the gripper to different kind of surroundings and other parameters. And these intelligent grippers are controlled either with industrial Ethernet or IO-Link. So when we look at industrial Ethernet and other communication interfaces, we have a very high variance. So there are many communication interfaces from field buses to industrial Ethernet. And if we want to launch a product which is intelligent and which has a interface included, we have to decide which interface we want to use. The problem is that then the customer who is using another communication, it's always very difficult to integrate the product into the control system. And so this was also a reason for us to develop IO-Link products, because IO-Link is open, and with an IO-Link master, it is possible to implement the same product in different kind of control systems. So we use IO-Link as a universal technology to support also different communication systems, and not only like Profinet or anything else. So I want to give you an overview of what function is possible to do with a gripper. As I already explained, with the alternative pillar, digital IOs, with the IO-Link interface, and with an industrial Ethernet interface. So the basic function is gripping and releasing. This should be possible with all grippers in general. Then we have an adjustment of the gripping force. So this is also possible with digital IO gripper, but only manually. So we have a turning switch on the gripper itself, and the gripping force can be adjusted manually. But this is not like very good during the complete production, because it's a manually, a worker has to go to the gripper and adjust it manually. So this is not very useful. With the IO-Link gripper, it is possible to adjust the gripping force through the PLC, so it is more flexible. Same as for industrial Ethernet. Positioning of the jaws, this is not possible with a digital IO, because I don't have any possibility to control the motor or the gripper. With IO-Link, we have the possibility to move to different positions all over the stroke. Same for industrial Ethernet, and which is one thing which is not possible with an IO-Link gripper is to define motion profiles at the gripper. So this is only possible with our industrial Ethernet grippers, which means that the gripper can accelerate, decelerate very slowly. In an IO-Link gripper, we defined a movement profile, which is always the same for every movement of the gripping fingers. One more benefit, as I already explained, of IO-Link is the sensor and diagnostic functions that we get. So for a digital IO gripper, it's only possible to detect the positions of the gripper, and only with an external sensor system. In that case, we mostly can only detect 2 positions, open and close, or maybe 3 with workpiece gripped. With IO-Link, it's possible to position over the entire stroke, so several positions over the complete stroke. We also get maintenance and diagnostic messages and identification data, like the material number, the serial number of the gripper, and other stuff which is necessary to maintain or to change the gripper. With an industrial Ethernet interface, we also get extended data of the drive which is inside the gripper, for example, about the speed, about the motor current and other stuff. We get it directly from the motor and the motor encoder. So, but still we have like IO-Link, which is doing, or which can do many functions that are not possible with digital IO. So this was like a theory, but now we come to the practical part. We have a gripper which is called PGN+E. It's an electrical universal gripper, and we have 2 versions of that gripper. On the one hand, we have a version with digital IOs, and we have one with IO-Link. And we can see at that product the benefit of IO-Link. So here, the gripping part can be done by both grippers. Positioning is not possible with the digital I/O gripper, only with IO-Link. The feedback that we get from the position is here only possible in 2 positions, and with IO-Link we get the complete stroke feedback. And also the diagnostic and status information. We don't get it from the digital I/O gripper, but for the IO-Link version, we have also that information. And as you see in the picture, from the optical point of view, they are nearly the same. So what we've done is only to change the electronics inside the gripper, and we've done also the electrical connection a little bit different, and that is how we generated the IO-Link version. So as a conclusion, what are the benefits for such an IO-Link gripper? We have a consistent control and electrical connection of all IO-Link products. We have the power supply, the control of the gripper, and the monitoring only with one cable. We don't need any external sensor system or something like that to have more cables, so we have only one. The communication is very stable and robust, so we don't have any interferences. We have a higher flexibility of such products compared to a product with digital I/Os. And we can integrate these products very easy into existing and new control systems using different IO-Link masters. And the last thing that I already mentioned is that we get information about the status of the gripper and more information. So for us, IO-Link is like a bridge connecting technologies. So as I already mentioned, on the one hand, we have digital I/O for very simple gripping applications, and the industrial Ethernet for the largest range of function. And a customer who is needing more than only a simple gripping application but does not want to have the premium product with all the complete function, IO-Link is a good bridge technology to close the gap between these 2 products. So what are the prospects in future? For us, IO-Link products can lead to a higher benefit with existing mechanics and technology. So as you have seen, we didn't change anything about the techniques, the mechanics, but only with the integration of IO-Link, we did get a lot of benefit out of the product. So with IO-Link, the flexibility in production can be increased because we can adjust different parameters according to other information in the process. And the parameters and information which are transferred through IO-Link can be used for actions, for example, for maintenance or something like that. Buzzword, condition monitoring. So for us, IO-Link is a door opener for Industry 4.0. So to get more information out of the product directly on the workpiece and to initiate actions for further production. So are there any questions? Feel free to ask them now or later in the break, and I want to close with thanking you very much for your attention.